Yes, that's right. This is the problem we solved on the first part of this lesson. But let's make a slight change. Let's take this greater or equal sign and let's change it for a lesser or equal sign. And let's see how this little sign switch is going to change our solutions region. So one more time, we're learning the graphic method. So we need a graph, and we're going to graph both of these inequalities, starting with the top one, the one that we just changed the sign. Remember, for the line, this line with a y-intercept of -8 and an x-intercept of 4, we learned this on lesson 6.1, part 3. But then again, that line is just the graph of the equation, and we have an inequality because this symbol means that the 2x minus y is lesser or equal than the 8. So this time, because it's lesser means we are below the line. So instead of graphing the top part of this line, we need to cover the region under the line. So the lesser sign means we go below our line and we cover everything below our line. And then one more time, let's not forget that we do have the little line representing the equal sign, meaning the 2x minus y is also allowed to be equal to 8. So our line is a solid line because we are allowed to have points lying on this line. Then we move on to the next inequality, x plus y is greater than 1. One more time, if you don't remember why this is a line with a y-intercept at 1 and an x-intercept at 1, just review lesson 6.1, part 3. Then again, this line just represents the graph of the equation, and we have an inequality. X plus y is greater than 1. So because x plus y is greater than 1, it means we have to paint the top part of this line. But one more time, we do not have the equal sign on this inequality, so we're not allowed to have points on the line. So this line, instead of being solid, needs to be changed to a dashed line. And now that we have the dashed line, we let clear that we cannot have points on the dashed line. We just paint the top region because it's greater than. X plus y is greater than 1, so that means above the line. We're allowed to have any point above this line. There we go. We have our two regions, the two regions that represent our solution. But what is the actual solution for the linear system of inequalities? We need a solution that meets the criteria for the two inequalities because this is a system. They are connected. So all we have to do is look at the region that they both intersect. They both intersect in this region. The two solutions intersect at the yellow marked part. So this is our solution. That intersection region is our solution. We can delete everything else, and our solution is any point lying on the yellow section. Well, let's fix it because one more time, we don't have right or top limits here. The only limits are our lines. And since we cannot have anything on the purple line, let's turn that into a dashed line. And this is our solution. Any point that lies on the yellow part is solution to our linear system of inequalities. Let's pick a couple of points. This one, the x value is 8. The y value is -4. That's a possible solution. This other point, the x value is 10. The y value is +8. This is another possible solution because those points are on the region. We can plug them in and we will see that they will meet the two inequalities. So that's why we find regions for linear systems of inequalities, because any point that is on that region and we find their x and y coordinates, as we plug them in our linear system of inequalities, they are going to meet the criteria of the two inequalities. So one more time, linear system of inequalities have different solutions, has a region of solutions.